Section 2.4 Applications. In this section, we will solve the triangle problems using an angle of elevation, angle of depression, and the bearing of a line. Definition. An angle of elevation is measured from the horizontal up as you look up at the object, and an angle will be inside of the triangle. An angle of depression is measured from the horizontal down, and it will be an angle outside of the triangle. In this example, the angle of elevation of the top of a pole measures 48 degrees from a point on the ground 18 feet away from its base. Find the height of the flagpole, which is x. Based on an angle 48, x is the opposite side, 18 is the adjacent. We used the tangent function, which is the tangent 48 degrees, equals the opposite x divided by the adjacent 18 from the definition number 2. So we can solve for x by multiplying 18 both sides of the equation to get 18 multiplied by the tangent of 48 degrees. Use the calculator, we will get the answer 19.99, or is approximately equal to 20 feet. The next example, Mick looks out from his executive office window after a big lunch and sees his Mercedes parked 500 meters down the street. If the angle of depression to the car is 56 degrees, how far up the building is Mick's office? From the top of the building, look down. That is an angle of depression. As you see, the angle is outside of the triangle. So the other angle within the triangle would be 90 degrees minus 56 degrees, or 34 degrees. The distance from the car to the building is 500. Redraw the triangle. The angle 34 degrees, and the opposite of that angle, the side opposite to that angle is 500 meters. We are going to find the height of the building. Use the second definition of the trig functions. The opposite and the adjacent, we can form the tangent function 34 degrees equals the opposite, which is 500, divided by x. Therefore, we can solve for x by cross multiply to get x equals 500 divided by the tangent of 34 degrees. Put in the calculator, we get it approximately equal to 741.28, or if we round it to the nearest meter, would be 741 meters. In this example, a ladder on a fire truck can be turned to a maximum angle of 70 degrees. And can be extended to a maximum length of 25 meters. If the base of the ladder is mounted on the fire truck 2 meters above the ground, how high above the ground will the ladder reach? We are going to find out what is the height from the top of the building to the ground, which is the portion of the right triangle added by 2. If we let this portion of the triangle to be x, so the total height gonna be x plus 2. That's what we are looking for. First, we're gonna find x. By looking at the right triangle with the angle 70 degrees and 25 meters, which is the length of the ladder, which is the side that opposite to the right angle or the hypotenuse, and looking for x. X is the opposite, 25 is the hypotenuse. We can use the sine 70 degrees equals the opposite x divided by hypotenuse. To compute x equals 25 multiplied by sine of 70 degrees, or 23.49, or is about 23 meters. And then we find the total height, find x plus 2 as the total height. Therefore, the ladder can reach 23 plus 2 meters above the ground. Since 23 plus 2 is the x plus 2. Remember, 2 is the height from the ground to the top of the truck, which is 25 meters. Next example. From the point on the floor, the angle of elevation to the top of the door is 48 degrees, while the angle of elevation to the ceiling above the door is 57 degrees. If the ceiling is 10 feet above the floor, what is the vertical dimension of the door? Round your answer to the nearest tenth of a foot. By looking at the figure, we are going to find out what is the vertical dimension of the door, which is the x. From two triangles, if we break them out, we draw it as the smaller triangle and the bigger triangle. The height of the door, which is x, which is the opposite side of the angle 48 degrees. And then the height of the bigger triangle, or the side that opposite to 57 degrees, is 10 feet. Both of them have the common base. So first of all, we are going to find out what would be their common base. Let it be the letter B as the base. To find B, we are going to use the larger triangle. Since we know the opposite as a tan, opposite and adjacent, we use the tangent function. Tangent 57 degrees equals tan over B, or B equals 10 divided by the tangent of 57 degrees. Using the calculator, B will be 6.5 feet. The problem asks you to write the answer as the nearest tenth of a foot, so B is 6.5 feet. After we get B, we're going to use B to find X. To find X, since B is 6.5, X is the opposite, B is adjacent to the angle 48 degrees. We use the tangent function again. This time, tangent of 48 degrees equals the opposite X over adjacent B, which is 6.5, or X equals 6.5 multiplied by the tangent of 48 degrees, or X is approximately equal to 7.2 feet.